Okay, hi, welcome back to Matlab the language. In this episode, we're going to build on our kind of different types of variable that you can create by looking at data structures and kind of variables that you store types of data in. So let's get right into it. The first one is cell. So this variable E is a cell, and let's just have a look at it in the command window. Okay, so this is a cell array. Contained within it, we have a number, usually indicated by these square brackets around it. We have a character, which you'll remember from last episode, is just a letter. And you can see here we have a string. So cell arrays are really useful because if you wanted to have a lot of different things in the same array, cells let you do that. The way you define a cell array, like when you're making matrices and you use square brackets, a cell array uses curly brackets. So if I create curly brackets with just a 1 in it, see answer there is a cell with number 1 in it. If I do multiple things in it, separated by commas, and let's have the character 8. So this can get kind of confusing, but you have to distinguish between the character 8 and the number 8. So for example, if I said add 1 to character 8, it would be like, can't do that. The reason is because it really does see it as just a word or a character. It's like if someone asked you to add 1 to the letter A, it doesn't make any sense. And there you go. So you can see it has all these different types of data within it. In the same way as matrices, you can indicate... Oh, by the way, if you press up and down on the command panel, you can just kind of go to previous commands. That's just kind of a handy little thing that I do sometimes. Just as with matrices, you can create kind of columns and rows. So if I do a semicolon here to indicate a new row and then go, 1, 7, 4. It creates a kind of grid. Same as with matrices, it has to be a rectangle. You can't just kind of leave bits blank or have different lengths of thing trying to stick together. And the same as with matrices, you can index it. However, with a cell array, there are kind of 2 ways that you can do this. So you can either access the cell or you can access the content of the cell. So if I go E and then just regular brackets, so indexing like we have been before, first row because there's only 1 row, and then 2. So that gives me the middle one from E, which as you remember was the character 1. But the type of the answer it gives me back isn't character, it's cell. Because I've used regular brackets, I've just accessed the cell. If I want to get out what's inside that cell, I need to use curly brackets. So I go E, curly brackets, 1, 2, close curly brackets. See now, the type of answer is character. Because I haven't accessed the cell, I've accessed what's inside of it. It's very easy to kind of tie yourself in knots using cells. They are incredibly useful for just being able to carry any kind of data. If you want to take a whole bunch of different things and stick them together, Matlab will quite often really not want to do that. So cell arrays are a really great way to kind of make it, stick it all together. It's particularly useful for kind of compiling outputs. So let's say you were gathering a logical true or false answer as one kind of data point for experiment, and then you're also gathering response times as a time array, and then you're also gathering, let's say they have a slider that they have to choose from, and that gives you a number, and you want it all to just be in one big output. Cells are really useful for that because you can then save that quite easily. But at the same time, it's really easy to end up with these kind of horrendous multi-layered things where it's a cell within a cell within a cell within a cell, because as I said, we're getting into kind of storage arrays now rather than just straight up data types. So you can put anything in a cell including another cell. So if I went in curly brackets and then more curly brackets and then the number 1, so it's a 1 by 1 cell, and if I go answer 1 1, within that is another cell, and we go answer 1 1 again. Finally we get to the number. So it's important to be wary of that when you're using cells. The next data type I want to go through is table. So I've got 2 examples for this. I've got this variable f and another variable g that I'll get to in a minute. So tables are kind of similar to cell arrays in that you can store different kinds of data together. However, tables are organized kind of firstly into columns. They generally like columns to all be the same data type. Of course, what you can do is just put each cell within the table as being a cell data type and just put data in it that way and kind of trick it, but that's kind of a cheap, nasty way of doing it. The big kind of advantage to tables over a cell array is that you can name the columns and the rows, which makes it so much easier to understand your code when you're going back over it. Because rather than just being like, okay, row 4, that was the response, and having to just remember that the fourth column or whatever was the response to the participant, you can just call it participant response. So tables can be accessed in the same way as matrices. So if I go F1, 1, there it is, that tells me it's from column 1, row 1. However, you can also access it by using what's called dot indexing. And this lets you kind of access by column name or by row name. So if I say f dot col 1, there we go. So that is the first column, 1, 2, 3, 1, 2, 3. I can also, so when I do the brackets, like with the matrix indexing, rather than giving it a number, you can actually give it a character array rather, which you can make the name of the column. So if I say f and then character array col 1, sorry, I just realized I've fallen foul of that. I've done it the wrong way around. It should always be row first before column. Row 1, col 1. There we go. It will give me that particular cell. So that's how you kind of index back into tables. As with a cell, you can also access the data inside the particular cell of the table. So if I just go back to that last command, only rather than doing round brackets, I will do curly brackets. So there we go, rather than giving me the row name and column name and it being a table as an output, it just gives me the number inside the table. So that can often be quite useful. Now, unlike cells and matrices and things, it's a bit more complicated to define a table. Well, there are a couple of ways of doing it really. The kind of standard way is you create all of your columns first. So let's say col 1 equals just a matrix. And it's best to just keep them one wide, so just have it all the next line. So that it is it's a column. Say col 2 will equal cell array of characters. So let's go A, B, C, D, E. Another thing about tables, it always has to have the same number of rows. So there we go, cell array. And then you would just use the function table. So any kind of word with the brackets after it is a function, and you just give it the input of col 1 and col 2. So you just separate all the different columns by commas. And there we go, it'll make a table that looks like that. You can then assign row names by this kind of arcane procedure. I'm not a big fan of it, but it's T, sorry, not T. It is whatever you assigned your table to, so I just put mine in ands because I've been lazy. So let's just go, let's go tab equals ands, just to store it in a variable so it doesn't get overridden every time. So let's go tab, and then you have to go dot properties, dot row names, and then you have to supply it with a cell array of character strings. So let's go, and you have to use the same number as you have rows. So I'm going to give it, I'm just going to copy and paste because, as I say, I'm lazy. Okay, row 3, row 4. So we've got a cell array that's 5 long. Oh, sorry. There we go. And so you can see it's now named all of the rows. The columns will automatically have the names of the variables that you gave them, but if you want to change the names, it's whatever you call your table dot properties dot variable names. You have to get the capitalization right as well. That's quite important. And then you just supply it with a cell array that's the same length as the number of columns. So there we go. So rather than being col1, col2, it's column1 and column2. It's just if you wanted to give them kind of nicer looking names. To show you an example of how you would use a table in a kind of research setting, here's one I kind of prepared earlier. So this table G, it has all these different types of input. So we've got time, we've got a logical, and we've got a number here. So if you scroll down, so you can see the column all has the same kind of thing within it. You can have different types of data in different columns. So this is, I think, is an example output from one of my recent experiments. So this was their GSR reading, I believe. This was, they were playing a video game. This was, I think, whether or not they'd just taken damage, and this was just the corresponding timestamp. So this is called a trial table. People often construct them at the beginning of their experiments. They'll define, what the conditions for the experiment are, and what condition this trial is, and you also kind of output data into it. Doing it that way and having this one big table that you put all of your data in and you draw all of your data from is generally a better way of doing things than just having loads of kind of variables just floating about, because it means that when you come to saving, all you have to do is just go save this table as an Excel file or something, and then you've got all of the data that you need. The final data type I want to go through with you is structures. Structures come in two flavors. There's scalar and non-scalar. So a scalar structure, they're similar to tables in that they have named fields that you can access by dot indexing. However, they can kind of be whatever size and contents you want. Structures are sort of, it's like having folders in a computer. It's kind of just an easier way to organize things. Okay, so let's try kind of indexing this example structure that I've made. So if we double click H to open it in here, as you can see, it's got 3 fields, so it doesn't lay it out like a table. So in the field string, it's just a single string, and in time and logical, it's a bunch of duration values and a bunch of logical values. So we'd index this by going H dot and then the name of the field. So let's say string. Look, a string. And then if we go H dot time, it chucks out just the whole thing. So that's a 200 point array. Non-scalar structures are much more similar to tables in the way they work. So if we double click here, so at first glance, it's kind of hard to tell really what the difference is between that and a table. And they are very similar. A non-scalar structure basically means it's still limited in that it has to be the same number of rows. But unlike a table, it's more kind of direct. So a table has cells and there are things within. So if you do a normal bracket indexing of a table, so let's say G row 1 column 2 brings out a table. If we do the same thing with a structure array, we can go I, let's go row 2 column 2. It does not like that. So a table kind of recognizes these as columns. A structure sees them just as fields. So instead, I go I2, so it's essentially the second row, and then you have to use dot indexing like you would a structure. So logical, like that. So a non-scalar structure is kind of just like a lot of scalar structures that are only one long, stuck on top of one another. This difference is pretty pedantic and it's quite often easy to get tripped up on it. My advice is to mostly use tables if you can, and to kind of leave this until you're a lot more comfortable with the language in general. However, once you do start using structures, it can dramatically improve the quality of your code because, again, rather than having just numeric arrays and just trying to remember what particular row and column corresponds to what, you can actually name things. And putting structures within structures is a really great way of having almost like a folder structure on a computer. So as I say, you can make a field of a structure and have that field contain a structure. And you can kind of string dot indexes together. So you're like I.logical dot the field name of whatever is within that field. And once you do that, I think that really does open up a whole load of possibilities. But when you're just starting out, I definitely think it's best to try and keep your data as simple as possible to avoid having to deal with any kind of complex concepts or having to distinguish between scalar and non-scalar arrays and that kind of thing. In the next video, I'll be going through kind of how to define your own functions. So rather than using the functions like input that we've been using so far, you can actually write your own, save them, or put them inside a script and call them and start doing stuff that way. So as always, thanks for listening, and I'll see you in the next episode.